My name is Kareem Gebaly, and this is work I've done with Lukash Gulab and Gebaly, my supervisors. So the goal is data exploration for everyone. So data is becoming more available on the web for everyone, and basically we have open government, we have data that's available readily on the internet, so often referred to as data democratization. So if we have data democratization, why not have analytics democratization? So basically, we don't want to make the life of the data expert better, easier. So people like the data scientist, data analyst, or the data journalist, we don't want to help them, only help them. We also want to make the non-data expert users, like the audience of the data journalist, to participate in the analytics and take part in the analytics and the data exploration. So how can we do that? We want to make data analytics and data exploration easier to use, such that it does not require lots of system knowledge from the user. And easy to interpret, such that it does not require a lot of expertise in analytics in order to understand the output of the analytics. And we don't also want it to require special infrastructure, special tools, special integration points, or pre-configurations, or adds a lot of system administrative work. So what did we do? We have plugged a full-fledged SQL system, RDBMS essentially, inside the web browser, and we call that Afterburner. And we have also plugged a data exploration tool called explanation table, and it also runs inside the browser. And the main challenge here is to make those two work with latencies that are comparable to native techniques. So let me give you an example of a data exploration task to put this into context. So let us assume we have several smart fridges, okay? And the smart fridges are aware of the items put inside them and the season, and they keep track of the item, whether the item expires or not. And let us assume that we are worried about why those items expire. So we go to the data, okay, and we try to explore an item of interest, an attribute of interest, such as expiry. So at the highest level, we can look at the entire data set, and we find that items 50-50, there's a 50-50 frequency, 50-50 chance that items expire, okay? And this is expressed by the pattern that matches the entire database, which is basically match all pattern shown on the top. And then we can be also interested in the expiry of different items. For example, cheese, cherries, chocolates, and we want to know the frequency of their expiry. We can also be interested in the season, winter, summer, spring, etc., or the location. We can also be interested in the combinations of those attributes. And just looking at those combinations is those combinations are too many, and just and visiting them and looking at them will overwhelm the eyes of the user, because those combinations in this data cube of the table tend to be too large, too many for the user to grasp because of the curse of the dimensionality. So this is what an explanation table does. It picks the most informative patterns in the data cube and shows them to the user. So hopefully those most informative patterns are going to be the ones that are most interesting for the user to start the data exploration journey from. Good starting points for the data exploration journey. So basically, for more information about how to build explanation tables, I refer you to the full paper in VLV 2014. Now for the second part, which is required for the data cube exploration, mainly the SQL heavy lifting part. For that, we use Afterburner. And Afterburner basically is an in-browser SQL engine that's basically uses state-of-the-art optimizations from the analytics field. So basically, it uses columnar layout and code and query compilation. So how fast is Afterburner? Basically, it's comparable to the state-of-the-art analytic systems that are running on the same machine, given the same resources. For more details about Afterburner, I refer you to this year's Sigmund demos. So now I will show you a demo of okay. Okay, so this demo is available online. You can view it from your laptop. You can view it from your tablet. You can view it from even your phone. Okay, and that's the whole point, that it is portable. Okay, we're back. Sorry about that. So in this data exploration scenario, basically I did not prepare anything. There is no back end supporting this data exploration scenario, and I did not install anything special on my client. I just have a normal web browser, and the first thing I do is basically I initialize Afterburner, which is my in-browser SQL. Okay, so now it's running. Apologies about that. So now I've initialized the in-browser SQL engine. Okay, so in this demo, I've prepared for you a few data sets that you can pick one from. Okay, so let's say we are interested in adult income. So we will load the data, the database inside the browser, and then we want to explore this data set. So what's actually happening right now is that the explanation table was built inside the web browser, no dependencies, and basically I've loaded the adult income dataset, and the adult income dataset is basically a relational table with different demographic attributes. So it has things like work class, marital status, education, and etc. And for every tuple in this dataset, we have the basically income. So whether the row has high income or low income. So for the highest level, basically we have 25%. So this means that for my entire data set, 25% of the rows have high income. For the second pattern in the explanation table, the never married 5%, which means that for the group of the never married in my data set, 5% of those have high income. The third pattern is basically bachelors with that are married, okay? And this is 70%. So basically, this is interesting because this number is larger than the average, and that's why it is picked. For the fourth pattern is basically divorced 10%, and the fifth pattern is executive managerial. And you can see that explanation tables help me create an easy to interpret summary of the data. But those patterns are also happen to be patterns in the data cube of the table. Okay, so they can define a good entry point for a data exploration scenario. So let's take, for example, I'm interested, which is basically married with a bachelor's, okay? And let's say I want to compare this group with similar groups. So I want to do a roll-up. So I can add this pattern to the control exploration panel and change the status from married to all. And I can visually see that for the people who have bachelor's degree, different statuses are similar to the average of the entire data set, except for the people who are married have higher frequency and higher chance of having high income. Another thing I can do is basically be interested in the same group, but I want to zoom in that group. Okay, so I want to do a drill down. So again, I can add the third pattern to the control exploration panel, and then I can, for example, want to investigate the effect of the working class. So I can change the work class to all, and I can see the different within this group, the different work class, and I can see that the distribution doesn't change a lot. Maybe there is nothing that's interesting here. So yeah, so I lost my slides here, but in conclusion, basically we have a portable way to basically explore the data cube, which is easy to use and basically easy to share and easy to interpret without lots of background in analytics. So that's, any questions?